Alright, so in this tutorial here we'll be looking at the proper technique in making solutions. For this demo here we're going to be using copper 2 sulfate as our compound. It gives us a nice blue color as a hydrate. When we dissolve in solution it's still going to be blue. So later on when I do a dilution it'll be slightly more interesting. So we'll start off with the container. We usually start off with a beaker here because it has a nice wide mouth, so especially for powders like this, as I add some water to it here, because of this wide opening here, it'll be very easy to actually dissolve things directly on the beaker. So we're going to start off with the beaker here. The scale was zeroed. I'm going to put it on the balancer. That's the starting mass of the beaker. You could record that down if you like, or what you can do is you can just tear it. You can re-zero it there. It just forgets the mass of the beaker. And now what I'm going to do is I'm going to take my copper 2 sulfate, just for this tutorial here. Let's say the experiment called for 2.5 grams. So I'm just going to grab some of this powder here. I'm going to pour in a little bit. Okay, try to hit 2.5. Now the thing about any experiment here is there's nothing magical about the numbers that they say. So maybe we calculated here 2.5. Oh no, I got 2.61. You could hypothetically take some powder out. You notice I have some extra here. Again, just demonstrating you don't want to put it back into the stock container. If anything, we do need to toss this. So it's always better to start on the low side. If you need more, you can grab more. But what I'm saying here is for the calculation, we can actually start off with the number 2.61 instead, and that way it'll sort of adjust the concentrations for later on. So let's say I needed this 2.5 grams, that's what the lab manual says. Whoops, I got too much. I'm just going to record this down here, 2.61 plus or minus 0.01. See a little bit of flickering there. I'm just going to pull this out of the way here. And let's say I want to make a solution of 100 milliliters. Now the thing about a beaker here is, although this one here does have the marking here 100, you'll notice the spacings between the sort of unnumbered divisions and the numbered divisions here, you'll notice it's fairly wide. Beaker's job is not actually really good in giving you volumes. It's actually much better in just giving you an approximate. So eventually what we want to do, if I really wanted to hit exactly 100.00, instead of trying to use a beaker here, we're actually going to switch over to use what's called a volumetric flask. A volumetric flask similarly here has a wider bottom. It has one mark like a pipette, and that one there has been well calibrated. Because this is 100 ml volumetric, that single mark that we get to is actually going to be 100.00. All right? So I'm just going to take this powder here. Because the volumetric flask here has a very narrow neck here, it's going to be really hard if you dissolved it and you try to mash a powder in here. So what we're going to do is sort of best of both worlds. I'm going to add some water here directly into my beaker first. I know that this 100 marking isn't super precise, so I'm just going to add a little bit of water. Just make sure you're under the 100. You're going to swirl it around a little bit here. You can even take a stir stick so we can just mash it up a little bit. And again, we're taking advantage that the beaker itself has a really wide opening at the top. You can crush up some of that powder on the bottom, just swirl it around. Okay. Again, the important thing here is I want to make sure I'm under this approximate 100 because I don't want to accidentally have overdone the volume. Okay. Sometimes powders take a little bit to dissolve, so I'm just going to mash this up a little bit more. Usually chemicals get a little bit more soluble when you heat things up as well, so if you're finding the powder really doesn't dissolve, you can gently heat it on a hot plate. Okay. But this one here should be okay. So copper 2 sulfate, it was the hydrate in the solid form, but once you dissolve it in water like this here, it's separated, dissociated the ions, so you definitely can't hold the water in the structure anymore. Okay. So that's pretty much dissolved here. What I'm going to do is, instead of trying to read the 100 ml mark over here, I'm going to pour it into the volumetric flask. So I'm just going to pour that in. Okay. Try not to spill any here. Okay. All right. And what you're going to find here is, because we were sure we were under 100 here, you notice I'm nowhere near the mark there. You'll notice even after pouring it here, there's still trace powder that's not dissolved yet. There may be a little bit of blue tone on the outside. What I'm going to do is I'm going to add a little bit of water here. I'm going to add a quick rinse. Okay. Add a little more water to try to dissolve the rest of the powder. In case some of the blue had actually splashed up onto the sides, I want to do this rinsing here. We're going to be transferring these rinsings here one by one into the volumetric to try to guarantee that all the powder, you see that there's still leftover powder here, so let's just do a couple more rinses. The thing about these rinses here is you want to make sure you are under the 100 mark, okay? Because if you accidentally go over 100 here, you need to start over again. Okay. So this is dissolving the leftover powder. You see us just transferring the rinses back to back here, okay. Still a little bit of trace here, maybe just one more rinse. Just gonna add a little bit more water, okay. Again, I just wanna make sure I'm under 100 because we're actually gonna use the volumetric to actually measure exactly 100 for us. That looks better, so no more powder left over. Okay. And then we're going to just transfer this rinsing here. Do this properly here, we should still be under 100. Right. That's why the approximate volumes are helpful, great. So we have our volumetric here, we're looking to hit the volume up to this mark, but so far we're still in this bottom portion. I'm just gonna pull away the balance a little bit here. And then what I'm going to do here is, because I'm pretty sure that the beaker is now emptied of the compound, I'm just going to add the water directly to the volumetric. Make sure you're using a flat surface here, and then you're going to be looking at eye level. For the first little bit here, you can add water just directly there, no problem. Okay. As you get up to the narrow neck, the volume is going to change very, very quickly. So what's going to happen here is, as you get really close to the top, it's actually a better procedure if you had an eyedropper or a dropper bottle here. As you get really close to the mark, I'm just gonna pull this up for you here. As you get really close to the mark that you're looking for, we're actually gonna use a dropper bottle or even an eyedropper. Do it by drops so that the bottom of the meniscus is perfectly at that line. That way there it's exactly calibrated for 100.00. So I'm just gonna look at this from eye level here. I'm going to squirt down a little bit of water. The water volume comes up very quickly near that line there. And here we go, the bottom of the line is at that mark. If you accidentally overdo it here, there's no way of pulling the water out. We would need to start over again, okay? Just to ensure mixing here, you can take a stopper cap here, cap the pipette tip here. You wanna make sure it's a tight seal. And then what you can do, you don't need to rock it back very violently here, but you just rock it back and forth, okay? Just to make sure all of that solution here has been dissolved, okay? Okay, all the powder has been dissolved. Okay, and there we go. We've made our solution. Okay, I'm just going to pour it out into another beaker here just for comparison's sake. I'm just going to pour this out into another beaker. I'm just going to pour this out into another beaker for comparison's sake here. So this was an empty beaker to begin with. As I pour it back here, remember a beaker's volume is just an approximate value there. And you notice here for the beaker, it actually looks like we're actually slightly over 100. That's fine. We're actually just using the beaker as a container now. I already know that the volumetric was perfectly 100. All right? So that's the proper way of making solutions. If you have any questions, just let me know. Thanks, guys. All right, so continuing on with our tutorial here, we're going to be doing some dilutions. I have a stock solution here of copper 2 sulfate. This is as concentrated as we're going to get it here. I'm going to be using a pipette here to pull 10 milliliter aliquots, 10 milliliter samples. I'm going to put them in each of these test tubes here laid out in front of us here. We know during a dilution here, although the volume might change, you may have extra water or you may have less solvent. When you boil off the solvent here, we're going to assume that the moles, the chemicals present actually remain constant. That gave us the formula here, C1V1 equals C2V2. I have a graduated cylinder filled with just water here. Just be careful that your V2 has to be the total volume. So if I already would have 10 milliliter aliquots, 10 milliliter portions, I would need to just add up the difference in terms of the water. So I'm gonna take my pipette here. This one here is a 10 milliliter pipette. Remember, this one single mark that we have here is calibrated for 10.00. I'm gonna take my pipette bulb here. I'm going to form a little bit of a seal on top. Give it a squeeze first. There's that negative pressure. As I hold the pipette tip here into the beaker, you want to make sure the tip stays under at all times here. And as I steadily let go of the bulb at the top, we're going to see that the solution steadily soaks upward. Because it might take a little bit of time to actually pull off the bulb and put your finger to make the seal at top, you're going to suck up more than you need. So I'm beyond the line that I want. I'm going to pull off the bulb here. You notice it dropped a little bit as I was doing that. I'm still above, so we're still okay. So what we're going to do here, I'm just going to wiggle my finger at the top there, slowly let that solution come downwards. If we're calibrated exactly at that mark here, I'm just going to have exactly 10.00, and I'm going to dispense that into the test tube in front of me here. I'm going to do this a couple of times here so you can see sort of a whole row of dilutions. Remember, concentration is intensive, meaning the concentration, the molarity actually doesn't change depending on what the volume is. So this concentration that I had in the stock will be the same concentration in each of these aliquots. I'm going to pull another aliquot here just to demonstrate how easy it is to pull these samples. So make sure the pipette tip stays under the water at all times. Usually if you have a more narrow beaker on the bottom here, it's a little bit easier to soak up solution, suck up more than you need. Okay. When you pull off the bulb here, you're going to wiggle your finger a little bit here until it actually is at that line. And again, when you have bottom of the meniscus here at that line, we can just take that portion out. Again, we haven't done any dilution just yet because I haven't added any water to it. Assuming you've done your calculations on the side here, C1 V1 equals C2 V2, if you know what total volume that you want, you can just add up the difference in water. So remember, after your pipette tip is sort of unloaded, there's still going to be a little bit of a droplet left. You don't need to force that part out. That's been calibrated for. For the next two here, I'm going to use my other pipette bulb here. I'm just going to show you this. This one here forms a nice seal. The nice thing about this one here is we don't actually need to pull it off and put your finger on top. This one can stay sealed at all times. You're just going to roll, right now here we're in the starting position. You're going to roll this wheel here. That's going to soak up solution. If you have too much, you can actually roll the wheel backwards. Once you're exactly at the mark here, I'm going to press this button here. As I press this button, it's just going to dispense the solution. So this is going to be slightly off screen here, but again, I'm going to put the pipette tip here under the bottom. I'm going to be scrolling that wheel there, soaking up the solution. If you don't happen to have enough here, you pull it off gently and then you put it back on. We can scroll the wheel a little bit more. Anytime you scroll the wheel here, the solution is going to go upwards, okay? Oh, I went over. Notice I'm not actually going to pull off the tip here. What I'm going to do here is I'm just going to scroll the wheel backwards. As I scroll the wheel the other way here, it gently lets solution out. That sort of saves you the hassle of having to pull off the pipette tip. You actually have a little bit more control. Again, when that bottom of the line here is at that meniscus there, you can just over top. We're going to press the button and that will dispense the solution into the third test tube here. Again, I'm just going to demonstrate what I've done here. At the top here, right now here, I had pressed the button to actually unload the solution. Right now here, we're actually not reset yet, so you just push this wheel downwards, okay? Now we're fully reset here. I'm going to put this under the solution again, scroll it backwards. This is going to soak solution up. If you want to get rid of solution, you just roll it the other way. So starting position here. So we're going to soak one last solution. Sort of a closer look at a pipette here. So there we go, we got it all in one. I'm going to scroll the solution back a little bit here, still a little bit too tall. Oh, we went too far, just scroll it. Just roll it back and forth. Okay, again, you don't need to pull off this tip here. When the bottom of that meniscus here is at the line, we know we have exactly 10. And again, what I'm going to do here is I'm going to be pressing on this button here. As I press the button, it's going to unload the solution into the last test tube for us. Okay. So I had pulled 10.00 milliliter aliquots out of my stock solution. The concentration in the beaker is the same as these test tubes here. Imagine the beaker was like orange juice here. The taste of orange juice here in our starting container, in our pitcher, would be the same had I poured it out into 4 cups. And then now, depending on what dilutions that you want, C1 V1 equals C2 V2, you'd measure the volume here. You could even pipette that volume if it's a nice increment of 10 or 25, but for a graduated cylinder, there's some markings here. I think I'm at the 35 mark here. Depending on what volumes you want to add, let's say I wanted to add, let's say 10 milliliters. I'll leave the first one as a control. I add 10 milliliters to the second one here. Just want to add it carefully here. Okay. So let's say I double that volume there. The concentration in this solution here will be half what it was before. Or you can add a little bit more water to the third one here, and so on and so forth. Okay. So that would be a little bit more dilute here, and then we'll just add a little bit more water to the last one. Okay. And there we go. That's how we do our dilutions here. Just remember, V2 has to be a total volume. So the water added is going to be the difference in volume. We already had 10 to begin with. We're adding the extra little bit, and that's going to be what we use for V2. Thanks, guys.